presentation is about deploying machine learning models for bioarchaeological applications with the help of Docker and Streamlit. It is meant to be a beginner-friendly talk, hopefully. So, my co-presenter is...
I'm Chrysovalandis Konstantinou. I'm a computational scientist at the Cyprus Institute.
And I am Efthymia Nikita. I am an assistant professor of bioarchaeology at the Cyprus Institute. So let's start with the basics. What is machine learning? Machine learning is the use of statistical methods and algorithms that learn from data. It is used to predict for predictive purposes. It is being increasingly used in science, technology and engineering, and in this presentation we used it in archaeology. Now, more specifically, how did we use machine learning? We used it for a bioarchaeological application. Bioarchaeology is the study of human skeletal remains from archaeological contexts. One of the key questions we have in bioarchaeology is what is the sex of this skeleton that we study? Is it a male or a female skeleton? A primary method we used to estimate sex from skeletal remains is metric analysis. In other words, we measure the size of specific bones, usually the cranium and the long bones, but also other elements. And then we use machine learning to estimate if the sex of the skeleton is male and female and what is the associated probability of this prediction. So for this application, we used Python libraries to prepare our data, build models, and deploy the models in a web application. You can see at the bottom of the slide the specific libraries we used for these steps. So I already very briefly described the problem in the previous slide, but let me reiterate here. So our aim in this project was to build models that allow us to predict the sex, male or female, of adult skeletons using bone measurements. This is, as I said, a central piece of information for archaeology, and we use sex estimations for paleodemographic reconstructions, so when we need to know what is the relative representation of males and females in different cemeteries. Also, sex is an important factor in paleopathological analysis, because whether we are men or women very often makes us more or less susceptible to specific diseases. Sex is also an important parameter when we examine mortuary practices, so we can see if, for example, family members were buried together. We can see if there is a differential treatment of men and women, and from that we can then start drawing conclusions about the beliefs of past people regarding post-mortem beliefs and the afterlife. So what we did here in this specific application is that we used existing databases of bone measurements from the cranium and the long bones from groups with a global distribution in order to train our models. More specifically, we used databases that included thousands of individuals that come from various pre-industrial settings, and geographically they cover, as I say, the entire globe. So Europe, Africa, Oceania, America, not Antarctica. We didn't have Antarctica.
No, we didn't.
Okay. Now on to Chrysovalandis to explain the more technical aspects of our work.
As Effie explained, I'm the person behind the machine learning analysis and the creation of the web application, which we later Dockerized. And let me try to briefly explain how all these things come together. So currently Python is probably the most popular language used to analyze data and produce machine learning models. In our case, as Effie explained in this previous slide, we had thousands of data which mapped a set of measurements related to bones to the sex of the skeleton. So the first step we took was to analyze these models, was to actually use the data to create models that matched the existing data. And then once a model is produced, you want to create a web application which is going to accept, and here we see the web application we created. So these variables here, goal, null, PNL, BBH, etc., refer to various measurements one archaeologist can take from a skeleton. So the user enters the measurements in millimeters into these forms here, and the web application gives back the probability that the skeleton belongs to a male or to a female skeleton. And this is something we did by exporting models we created using the libraries Effie mentioned here, so scikit-learn and XGBoost. So we created these models using these libraries. We exported them using Pickle, which is a Python library that allows you to export machine learning models into byte form. And then you can import these models into the web application. Now, how can you create a web application using Python? So Python offers various web frameworks. Flask and Streamlit are some of the most popular ones, but there are others as well. These frameworks are imported into the code like any other library. And for those of you who write Python code, you know that when you write a Python script, on the top of it you have a statement import this and that library, etc. So this is exactly how you import Streamlit into the script that is later run to create the web application. So yes, running the Python script creates the web application. Okay, why did we use Streamlit? We found that it was really straightforward and easy to use, especially for beginners like us. It was the first time I created a web application, so I needed something simple. So if you know how to write Python code, you can create a Streamlit web application by using just a few lines of code, literally. Streamlit creates user-friendly web applications, and you saw in my previous slide that you have a really nice input form that is created using some lines of code. There is no need to know HTML, CSS, and JavaScript, though Streamlit allows you to write JavaScript and HTML pieces in your web application if you want to. And Streamlit is designed for data science applications, so it was exactly what we needed. And here I provided the script called Streamlit _app.py, which creates our web application. And you can see that here are the various libraries we used. So Pickle is one of them. We need Pickle because, as I said, we used Python notebooks to export models using Pickle. So you need Pickle to import these models now. Pandas is a popular library that we used. And as you can see, Streamlit is here, and it's imported as a library into the script. And by running this script, you then create the web application. And there are various other libraries we needed. Okay, now what does Docker have to do with all this? So let's first talk about what Docker is. So Docker is a software platform that allows building, testing, and deploying web applications quickly by packaging software into standardized units called containers. And why do we use Docker? So we use it because no matter what your personal system configuration is, you can run the web application as far as you have Docker installed and a Dockerfile with the instructions on how to build the image. And now I use the word image and container. And I'm going to explain what this means in a later slide. But before we do that, I want to stress that once you write this script on your local machine, and once you run the appropriate command, which is Streamlit run, this is how it's called, you write it on your command line. And by the way, I'm using a Mac. So if you go to your command line and you type Streamlit run and then input the name of the script, the web application is going to be created locally on your local machine. But this doesn't mean that everybody has all the libraries installed into their system, etc. So what I mean is that if I give this file to someone else and they try to run it, the web application will most probably not run because some of these libraries are missing, etc. So Docker bypasses this problem by allowing you to put everything you want into a nice image, and if you run that image on your local machine, you will have your web application up and running, and then you can give that Docker image to someone else and they will run it on their local machine and it will run and they will be happy as well. And you can also use the same Docker image to run and run it on a web server, and then that will create a website, which is kind of great. I mentioned the words Docker image and Docker container. So in this slide, I'm going to try to explain what a Docker image is, what a Docker container is, and what a Docker file is. So a Docker image is the base on which software is added. So you can think of it like a virtual machine that comes with Linux installed inside them. And on top of that Linux machine, you can put Python libraries, your own code, etc. Once you create the Docker image, and a Docker image is built in the build phase, this is how it's called. So once you create the image, you can run it. Running a Docker image creates a Docker container. So the Docker container is the running instance of an image. And now a Docker file contains the instructions needed on how to build the image. And by the way, when we create a Docker file, we initiate it with exactly that word you see there. So with a capital D and then Dockerfile, one word. So Docker images now can be downloaded from the Docker Hub. And you see the address to the Docker Hub here. The Docker Hub contains literally millions of images. And images come with a certain software package installed inside them, and they are usually they usually come with a preloaded Linux system inside them. So there is a search box up top in the Docker Hub website. So here I typed Python because this is what we needed. So Python is the first image shown there. And it's good to use official images, by the way. You see that this image has 1 billion downloads. And this image comes with a Linux operating system with Python libraries installed inside the image. Now, what is the relationship between Docker images and Docker files? As I said, a Docker file contains the instructions on how to build an image. So you can use Docker files to build custom images using base images. So what this means is that you see that on the first command we put, and these are this is the syntax of Docker. So the first command there is from, sorry, my computer froze. So using the from command, you can pull, this is how it's called, the Python image that we saw in the previous slide, this one, okay? And 3.7 is the version of the Python that is loaded inside this image. Expose 8501 means expose this port for the web application. Workdir creates a directory inside the Docker image, so inside the Linux system that is loaded in the Docker image. So that directory is called up and it becomes our working directory. The command copy tells the system to copy everything. If we specify copy ... we copy all the files from our local directory into the Docker image. And then the other copy command copies all the models found inside the models Goldman missing data folder into the folder app models Goldman missing data inside the Docker image. And again, the same for the other copy commands. We copy pretty much everything we need from our local system into the Docker image. Then run is a command that tells the image to run the pip3 command inside the image, meaning that after we run the command pip3 install -r, which means recursively requirements.txt, all the libraries, all the Python libraries specified inside the requirements.txt file will be installed in our image. Now the last command we see in this Dockerfile is the cmd command. The cmd command is not run in the build phase. It's run once we press docker run. So it's run after we run a Docker image and we create the container. So it's run in the container phase. So once we run the image, we run the command streamlit run streamlit app.py, which runs the web application. And let me show you the requirements.txt file. So the requirements.txt file contains all the Python libraries that we need to be installed inside the image during the build phase. And here are the Python libraries. So for example, we need scikit-learn, but we need the version 0.221. So that's why we use the double equal sign. But for pandas, we need anything from 0.19 version or above. This is why you use the greater than or equal sign. And as you can see, we also request that Streamlit is installed inside the image. After doing all the previous steps, we are ready to run our image and create a container, as I mentioned before. And to your right over here, you see what the final result looks like. Actually, this is the version of the app we have up and running onto the web server, and you can see the URL address which you can visit and see the app for yourselves. And in the final part of the video, I actually want to walk you guys through how to clone my repository from GitHub onto your local machine, build the container, and run it so that you have a web application up and running onto your local machine. In my GitHub account and the SexEst repository. SexEst is short for sex estimation. So if you go visit this repository, you can find instructions on how to have the Streamlit web application up and running onto your local machine. So the first step, which is crucial, is to have Docker installed on your machine. This command installs Docker on a Linux machine, but you can follow these links here to get instructions on how to install it on a Mac and Windows. So to build the Docker image, we start by, first of all, you have to fork this repository onto your local account. This is the first step you have to do. I cannot demonstrate this part for you because I'm in my repository. So you have to be in your GitHub account. Okay, so the first step is to clone the repository onto your local machine once you forked it onto your account. So this is the command needed. In your case, here you will see your username, not my username. Okay, I press enter, and voila, the repository is on my machine. Then you have to enter the repository, and I have the command there. So you cd into the repository, and if I list all the files, you can see the Dockerfile, the the README, the models needed for the application, and the script that produces the web application, etc. So the next step is to run the build command. So docker build -f means use the Docker file provided. -t means give the image the name up latest, and the dot means take everything found into this local repository, meaning these files, and put them into the Docker image. And if I press enter, you see that it starts doing stuff. And because this is gonna take some time, I'm gonna let you see what the thing does. So you can see that here it created the working directory, it copied files, now it's installing all the Python libraries from the requirements.txt file onto the image, etc. But I'm gonna stop here, and I'm gonna meet you again once this process stops, because it takes some time, okay? The build command ran successfully. You can see the steps here. All the libraries are installed, etc. So now all you have to do is to use the docker run command, and I'm gonna explain what this does. So the run command tells Docker to take this image and run it using these ports. The first port, in this example, it happens that the Streamlit app runs on the port number 8501 on our local machine, and it also runs on the port 8501 inside the Docker container. So once I press this process does not take a lot of time, it takes a few seconds. So you see that the command ran, and we can visit. Don't pay attention to this. We actually need to visit this URL address on our local host. We press enter, and it takes some time. And here is the web application successfully running on our local machine. And this is the part where we enter our measurements, etc. So thank you for watching our talk.